With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello student, this is question ID number 644357760. Question states that a thermally insulated vessel containing a diatomic gas of molar mass m is moving with velocity v. The temperature of the gas is T. If it is suddenly stopped, then internal energy of the gas is equal to 5 nRT by 2 when vessel is moving. There is no change in temperature if vessel is suddenly stopped. So there is a rise in temperature if vessel is suddenly stopped. Temperature increase is due to the heat input. These are the options. Let's do the solution for this question. Here, so there is a vessel which is thermally insulated from the surrounding. That means there is no heat transfer to the surroundings. So it is here gas molecules are here at temperature T. So the temperature of the gas is T and it is moving with velocity v. And when it is moving with velocity, what is the energy of this vessel? So that means at temperature T it is moving with velocity v. So they are thermally vibrating and they will increase the kinetic energy. And here the molar mass m is given. So that means molar mass, that is mass of gas molecules is equal to n into m, where n is the number of molecules and m is the molar mass. So when it is moving with velocity v, so there is a change in the kinetic energy. So the change in kinetic energy, with leads to change in temperature, or you can say that if you change the temperature, then the kinetic energy will also change. If you increase the temperature, then kinetic energy will also increase. So that means the change in the kinetic energy will be half m v square, and the half m is the mass, that mass of molar. That means this m is n m. So that means this is n m capital, and v is the velocity, that is change in the velocity. That means here you have to write that is delta v, that is change it. So initial velocity vi is equal to v and the vf is equal to 0. Now change in the velocity delta v is equal to vf minus vi. That means vf is 0 minus vi. It is stopped, that means the velocity becomes 0. So it is minus vi. So change in the velocity is minus vi, and it is because here it is a square, the delta v square is equal to vi square, that means v square. It is given that the initial velocity is v, so it is mv square. So this is the change in the kinetic energy, equation number 1. Now this, when the vessel is moving with velocity v, the internal energy of the vessel is, that means internal energy U is equal to of diatomic gas 5 by 2 K into delta T. Here K is the constants and 5 by 2, and the value of the K is nR into delta T, where K is equal to nR and N is the number of molecules and R is the gas constant. So that means when the vessel is moving with velocity v, this change in the kinetic energy will store as a U internal energy of the 5 by 2 nR T, because the vessel is moving at temperature T, gas molecules are at the temperature T, so this will be the U is equal to 5 by 2 nR T. So that means option A is correct. So this option A is correct. Now the vessel is stopped, so there is no change in temperature if vessel is suddenly stopped, which is not correct. If the suppose this vessel is moving and the gas molecules are vibrating, that means they increase the temperature of these molecules. So that means this is not correct. There is a rise in temperature if vessel is suddenly stopped. Yes, partially it is correct. There is a rise in temperature, but here if there is no heat input, then temperature will not rise. So here option D, temperature increase due to the heat input. So the option D is correct. So in this question, option A and D are correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.